Hi and welcome back to Programming with R and Matlab. My name is Ian and I'm Finance Teaching Assistant at Stockholm Business School. Today we continue our course coding in R and we're going to the train ratio sorting. This is the fourth block in our general algorithm. And what we'd like to do, we first would like to calculate train ratio. Afterwards we would like to sort stocks which have passed our Shaw operation, moving average rule, and at the end we would like to sort them from highest to lowest train ratio, and we would like to include the stocks into portfolio. So we'd like to select 10 of them which will have the highest train ratio, and then we include it into our portfolio. So this is the algorithm which we agreed to use in our basics video. We're going to run a regression to calculate the train ratio. Afterwards we're extracting beta, then we actually calculating train ratio, and then we're saving the ratio into the table. And as we have done with Shaw operation moving average, we're going to include it to load stock function. So let's go to our R code and let's go to load stock data. So here it is. Instead of empty space, we're going to write get train ratio, and then we don't know yet what we will need as an input. So here get train ratio. Train ratio. We would like to write it as a function, and let's now think over the input. So we would like to calculate so here I'm using expected return. Well, in fact I will use not expected return, I will use just log returns instead of this and this one when I'm going to calculate out the regression. It's completely okay for calculating betas, so there should be not any problems. So for here, to calculate our log returns, we need our prices, and the same thing to calculate mean, we need also log returns, so we also need prices. Risk-free rate is given, and beta can be estimated. So we need only the prices for our stock and the values for our index. So we would like to have prices, then we would like to have index, risk-free rate. Also we would like to have it time varying, so we need a num time. I think that's it. So now let's calculate log returns. So for this we would like to have stock log. So we calculate it in the same manner as we did here. So div log prices, and then also going to say index log. So going to difference log index. Then we would like to calculate excess returns. Calculate excess returns. Okay. For this, how we call it, excess, stock excess. Let's call it like this, stock excess. And for this we need to, from stock log, subtract our risk-free rate, but we're going to use only from second observation, because when we were calculating our log returns we get rid of one observation. So risk-free rate from second to the length RF. Done. And then we would like to have index excess returns, so index log minus again risk-free length of RF. So pretty much when we write in here length, we are trying to identify the last element in the RF vector. You use length when you deal with vectors, and you use number of rows and number of columns when you're dealing with matrices. Then we also would like to specify the empty vector for tr. Specify empty vector for training ratios. Then our tr is going to be vector, each element of which is numeric value, and the length is equal for each time period, so equal of time. Good. So now for id time in 1 to number of time, we would like to select such trainer ratio at id time is going to be equal our excess return, so it's going to be of the stock log starting from 1 to okay. So actually this is time period number 2. So at time point, so here we have to start from the second one, and then it would be id time minus 1. So pretty much when you would like think over the thing that we dropped the first observation when we're calculating stock return, so here we also kind of drop it the first observation. This is why we're starting from the second one, and then we are just can say id time minus 1. So at time period 2 it will pretty much refer to only one element here. Okay, and now minus risk-free rate at id time, and we would like to divide it by our beta. And to calculate beta, we're going to use a library which is called dinlm, and usually you would like to declare libraries before all the functions so that they are automatically loaded. So we're going to say library dinlm. This one is going to be used to run regressions. It's not automatically installed, so you have to install it manually before using it. For this you're going to leave tools, yes, and then you go install packages. Then you just write here packages dinlm, and then you press install, and then it's installing the whole packaging here. Good. Afterwards, when you're going to run the whole thing, when we're going to call the function in here, it will go in our function beta, load the library, and then we will be able to use regressions. So we're going to use kpm reg to store our regression output, and we're going to use the function dinlm. Here it is. So let's call some help. Well, it doesn't call. So pretty much what you would like to do when you finish writing dinlm. The first thing you would like to write a formula in here, and the formula you would like to use, you would like to regress your stock excess returns on the index excess returns. So then you just write stock excess. Then you need to write this symbol. It means that it's pretty much equal but used in regression like style. So it tells you that this is going to be regressed on this formula over here, and then you just write index access return. That's it. Then you can also add start, or you can add comment which is going to be start. It means starting from which point you would like to run the regression on these two variables. We're not going to use it because we're starting from the very beginning, but what we're going to use it is and we would like to end at a specific ID time, -1 actually. Why -1? Because this one is used because we dropped one observation over here, and then we're closing the bracket. The thing is that if you run like that, it will also include intercept into the regression. In order to exclude intercept, because we think that our model works correctly, we would write 0. So pretty much 0 here means that there is no intercept. Afterwards, our beta can be found with referring to the kappa m regression. And we would like to take the summary of this kappa m regression. For this, there is a special function summary. What it does, it takes this regression and reformats it into the more in a more appealable way, I can say, or in a more user-friendly way, so that we can then work with it. Pretty much what it will do, it will create a separate kind of list of matrix to which we can refer in the way we're referring to the name prices, MANSR. So we are going to write a $, and then we would like to write coefficients. So the first element is going to be usually intercept in the coefficients, but if you set this to be equal to 0, so we're taking rid of intercept, by referring to the first element, we're actually referring to the beta over here. So 1, 1. And as you can see, we are going to do it for each time period. So our betas are going to be time varying as well as our training ratio. Good. So let's take a look here. Okay, we need to write down the data. So we would like to include prices. We would like to include the value of our index, risk-free rate, and number of time. Okay. So the prices is going to be stock data ID. Then the same thing, but with ID equal 1, because we're referring to the index values, and the index is number 1 in our database. Then risk-free rate and number of time. Okay. Then it should work well once run. Well, we'll see. Let's save it, and let's go to our main code. So here we're going to use these trainer ratios to sort them. Let's take a look how we're going to do it. Uh-oh. Yeah, something went wrong. Okay, so we calculated the trainer ratio. We want to sort the stocks. This is what we have from another slide we had in our basics course. So what we would like to do, now we have this table with trainer measures. We would like to identify the one which satisfy all the shape ratio filtering, moving average filtering, and then identify sort them up and identify the highest trainer measures. So after sorting this table, we will receive two vectors. One is going to have former IDs, which can track the ID in the general matrix, and the other one is the trainer measures sorted. and then we would like to write them in to our final portfolio here. So let's now take a look at our code again. When we are including the stock, we are writing down 1. If we are not including, we are writing down 0. Actually, we don't need to know 1 or 0. We want to know the trainer ratios of the stocks which have the buy signal. And then we would like to sort them. So instead of including 1 or 0, I suggest writing down the trainer ratios from the very beginning, and then we're going to sort them. So here we're going to assign stock data. We would like identify the stock which have a buy signal. We would like to go to trainer ratio at the specific point of ID time. That's it. So after this, it will write down into our temporary portfolio the trainer ratio of a specific stock, and because ID here and ID here coincide, we can still track them in our general matrix. But if we do not want to add the stock, we cannot add 0, because sometimes trainer ratio may be less than 0, and we don't care if it is more or less than 0. What we care about is that the stock has to have the highest Sharpe ratio among other stocks which also have a buying signal. And to make sure that there is not going to be any interference with zeros, we would like, instead of 0, assign a very, very low value, so when it's going to be sorted, it's definitely not going to be included. And the lowest value in the whole universe is minus infinity. And you can write it like this, minus inf, and it means like, and the computer will treat it as minus infinity. Okay, we're going to apply all the ratios, all the filtering on the all stocks, but when you do the sorting, you don't actually need to include it in the loop, because there is a built-in function. So we're going to write it down, still in the general loop, but not into the one which does moving average and Sharpe ratio check. So after this, we're going to have the list of the stocks, and this list is going to be passed to the next kind of subsection of this loop. And we would like to call it sorted portfolio, and we're going to use function sort. And here you need to specify what you would like to sort. You would like to sort temporarily portfolio, and then in the next one you would like to specify if you want to be it increasing or decreasing. By default it's increasing, so the lowest are in the top and the highest in the bottom. So we need to say decreasing true. Also, we would like to know the number of indexes, because then it will just return the sorted list and without any IDs as we had in here, without the former IDs, but we want them to be included, so you need to tell R also to include them. You can do it by writing index return equal true. After running this function, it will a sorted portfolio will have two inputs. The one no, not inputs actually, two fields. One is going to be called X, which will have the sorted trainer ratios, and another one would be XID, which is going to have all the former IDs, so that we can track them into our temporary portfolio and hence in the big stock data database. So after we have our sorted portfolio, we would like to start writing down them into our general portfolio, but first we would like to create this general portfolio. We are going to write creating empty general portfolio. We're going to call it portfolio, and we would like to create it as a matrix which will have maximum 10 columns and such number of rows that will be sufficient for all the data points. So matrix, it will create a matrix. Then the first value is going to be which date you would like to use. If you write 0, it means that each element of the matrix is going to be equal to 0. Then you would like to write number of columns, 10, and number of rows, and here you would like to have it equal to total number of time periods, number of time. Good. So after this we created the portfolio, and what we would like to do, we would like to select the first 10. Well, usually you can just take the first 10 stocks from your sorted portfolio and copy it in, but let's think a little bit more. Can it be so that we can have only 2 stocks which will satisfy our algorithm? Yes. And if we have only 2 stocks, then we need to find somehow way to check if if we actually should include the third stock or not. To do this, we're going to run another loop, which is going to be ID. And you see, ID I'm using here and ID I'm using here, it's the same variable, but it's completely okay because this loop is gone. So after this loop will be done, the computer will start doing this loop. So usually it will, when the computer sees like for function, it will take this, take everything which is between 2 brackets over here, and will repeat them such number of times as you specify. But if there is also loop inside, it will then repeat this thing this number of times, then go to the next section of the code and then repeat it again and again. Okay, so we would like to do it from the first to 10th stock element, and what we would like to do, we would like to identify if this stock actually has a trainer ratio inside, because if the stock has a bind signal, so by bind signal I mean the moving satisfies moving average as well as our Sharpe ratio, it will write down the trainer ratio, and there could not be minus infinity trainer ratio. But then if you have a temporary, but if it does not, it will be minus infinity, and it doesn't matter how low stock this trainer ratio will be, it will be always bigger than the minus infinity. So to check if we actually have to invest in this stock, we can try to see if the trainer ratio in our sorted portfolio for the stock from 1 to 10 is actually bigger than minus infinity. And if it is, then we're including it into our stock. So if now we go sorted portfolio, we are referring to the sorted Sharpe ratios, to the sorted trainer ratios, and we would like to check if they're bigger than minus infinity, and it has to be strictly bigger here. If it is bigger, we would like to include it to our portfolio at a specific point of ID time, and we're using the element ID here. And if it is, and to include it, we will write down the index of a stock from the general matrix, and for this we use xid. Oh, excuse me. we are using ix, not xid, but ix, referring to the. So ix is actually to refer to the index, not xid. Sorry. Um, and after running this, we will have a portfolio which will store all the values of the IDs, which can be easily tracked to in our general matrix stock data, and it will show us the final portfolio. Okay, good. So right now we can run the code, and for this we need to again upload, because we changed the code in here, and we're not going to make any changes to log stock data anymore unless there are some mistakes which we will correct. Let's take a look. So we're running it, and you see it's loaded. So it has some warnings, but it's okay. Then we would like to run the stock data, and it may take some time, and hopefully it will calculate everything and we are not going to have any mistakes. So let's wait a bit. As you can see, it's still going on, and it has been calculating for more than 5 minutes. Well, it can be so that it calculates for that much long. The reason for this is that we are using here too many loops. So here we're using the same num time, and here we are using num time, and again we're doing it for each time period. What may be better is that you do one loop, but you're calculating all of these ratios simultaneously and not doing it in the separate blocks. Why we didn't do it, and why I didn't do it, because I just want to show it, first of all because I wanted to make it more like a structural way, and so that you understand that it's better to do it in some kind of way of structure, but also because if I would do it in one big function, let's say load stock data, I think it would be less understandable and less clear, and the code would not be that much easy to read for people who are not that much good at programming. So this is why I thought, well, the code is still going on. It was, I think, about 8 minutes. The reason why this code can go for that much long is that we are using too many loops in our load stock data. So take a look here. This one is okay, but for each command, get MA, get SR, and get TR, we're making a loop which will take all the time data points. Here again, time data points here. Oh, it will actually return an error. Okay. Well, I forgot to write here return TR, so that at the end we get something. And if you find something like I did right now, well, I have to be more attentive. You can always terminate the code. Here, you can press stop here, and then you can save the code again. And if you find something bad, you can just do any amendments what you would like. Like, for example, I forgot to write return TR, so that pretty much if I would run the code, it will do all the calculations, but it will just throw away this TR and will not write our training ratios at all. So you need to be very careful when you write the functions. Be sure that it will return something, so that then you can assign this value into the cell or the variable you want to work with. So let's upload the functions again and take a look what's going on here. Usually you would like to have as few loops as possible because they are taking a lot of time to perform, and the usually you even can get away without them. For example, how we did in here when we were calculating log returns. You see, you just use div, log, and prices. Pretty much you can rewrite the same thing with the loop, and it will be a little bit more power and time consuming, maybe. Maybe not power, but the efficiency of your code will slow down even more. So if you will find the way to optimize somehow the code and make it better, feel free to do it. It's only good for you, and definitely you don't want to spend all the time in front of the computer waiting until it calculates the whole thing just because you overlooped the whole code. So loops are very easy when you know how to use them, but at the same time the code becomes a little bit more complicated, more time consuming, and usually there is always a way to write it so as not to use loops at all. But of course sometimes it's just the easiest way to do. Okay, I think I will wait until it calculates the whole thing, and I will get back to you when the calculation is done. So see you in a while. Hi and welcome back. So I was sitting here and waiting until everything is calculated. Looks like it's done. It took, I believe, 10 minutes to calculate everything. Let's take a look how our stock data looks. So it has prices. Oh gosh. So good news, the right trainer ratio, which looks fine, and also sharp ratio looks pretty good as well. Yeah, it would be zeros. Yeah, you can by pressing here you can actually check out how everything looks like. Okay, so let's go and run the rest of the code and see how it will work out. Okay, we have error. Good. A number of items to replace is not a multiple of replaceable length. Okay, yeah. I made a mistake here. I need to specify because this is a vector. So I hope there is sorted. Yeah, sorted port. Yeah, luckily. Yeah, let's take a look. Sorted port. You see, there is 2x and ix. 0, 0, 0, 0. Why is it 0? Oh yeah, well, I believe it's because there was an error. This is why it was 0. Okay, and we are not specifying which element we would like to write down. We would like to write down ID element. So, like, it's going to change 1, 2, 3, 4, 5, up to 10. So this is why we need just to write here ID. Then after selecting this, it shall be fine. But this one I don't really like that it is zeros. It shall not be zeros, it shall be minus infinity. So just so that you know, if you have some errors when you select and run the code, sometimes it's better just to run each line separately, like this I'm doing right now, just to be sure that all of them are zeroed down. And then if you select the loop and run it, good. Let's take a look at our portfolio. Okay, looks fine. So as you can see in here, it starts selecting stocks from the very first day period. But the problem is that to calculate the moving average so that our algorithm works, we need to wait first 50 days so that we have data. So pretty much in here we need in fact to select not from the first time period but start from the 50s one. And then after the 50s time period we can go on and use our algorithm. So let's just put everything to the 0 again and run the code. Yeah, you see there was some warnings. Well, can run them to see what was wrong. The condition length, yeah, it's pretty much we're doing here is completely okay. The code is still working and only the first element will be used. Oh yeah, I didn't specify ID here as well. So right now what it does, it just selects only the first element, so everything we will have in our portfolio in fact is wrong. So do not forget to use the identifier. You see, I forgot to do it, and well, we got warning messages. So it's good to track them and see what actually it tells you. So what it tells you that it is a vector and you haven't specified which element of the vector you would like to use. Right now I specified I would like to use it so that the element will be changing from 1 to 10. And what it says, well, since you haven't specified, I will just assume that you meant the first element of the sorted portfolio X, and then I will compare it 10 times. This is completely not what we want to do. So let's run it again. It's zeroed, yeah, everything, and then we just run this whole thing again, and you see no warnings. And if you take a look right now in here, our portfolio has updated, and now we have the stocks selected. And let's take a look. Do we have, and well, we didn't have anything lately. And as you can see, we have also selected number 1, so the stock which has index number 1. And if you take a look, it's our raw data. Well, as you remember, I don't think you can actually take a look in stock data. Yeah, it's a list. So, but as you remember, the first element in our stock data, let's select it. Stock data, the first element. Oh, this was wrong. Yeah, it was our OMX 30, and we think that we cannot buy ETF. So if you can buy ETF, then it's completely fine. Then just to leave it as is. But just for fun, let's say that we cannot buy ETF, so that we can have we should exclude OMX 30. And where can we do it? We can actually do it in here when we are selecting the stocks and we are writing trainer ratio. If we would say that for the stock which has number 2, the trainer ratio will be equal, let's say, minus infinity, then we'll completely exclude it from our algorithm. And to do it, we're going to use one more function, if function, if stock data. Then we're selecting the element. So we're selecting the current stock which is processing. Or actually, we can, instead of selecting the stock, we would like to just select if the ID of this stock is more than 1. So pretty much if the thing which is in here is more than 1, that it's 2, for example, then we can just add the stock and we'll be good. Yep. So if we have the index OMX Stockholm 30, so that it's so ID is equal to 1, this will not happen. Instead, we would like to assign else. We don't want to include. Do not include index. And we're going to assign template ID minus infinity. Pam. And let's run this whole thing again. We will zero everything up, and then we will run the whole thing. Pam. And take a look at the portfolio. And as you can see, previously here we had 1, so it was selecting it was selecting index, and it's pretty much included index into our portfolio. Here we excluded it, so now it's completely zeros. So at the end we're actually not going to invest in any stock. Okay, so let's take a look what we have done today. We sorted the stocks and we included the stocks into the portfolio at a specific time t, and t is changing during the whole period of time. And we have crossed out the 4th logical block. So right now we need to show these stocks. Pretty much the whole robot is done, and in the 5th block we're going to make it more user-friendly, so that it's more understandable for us how we're going to implement it. So please press here to play next and final video. Thank you for watching, and have a nice day. Goodbye.